Hey guys, welcome back to day 2 of Unit 1. Before we begin, I just want to ask you a fun question. What does the age of a fossil, nuclear power plants, and your thyroid gland all have in common? The answer is that in order to determine the age of a fossil, in order for a nuclear power plant to operate, and in order for your thyroid gland to function as it should, it all requires what is called an isotope. And today we are going to look at what isotopes are. Today's objectives are that you can determine the number of protons and neutrons in an atom based on your isotope symbol. So it's going to be different than nuclear notation that we looked at yesterday. And you can also describe the similarities and differences in isotopes of an element. So our essential question today is pretty simple. What are isotopes? To answer that question, isotopes are atoms of the same element. Okay, so they have the same number of protons, the same atomic number, such as carbon, right? 2 atoms of carbon. But they may have different numbers of neutrons, right? They might have a different mass number. And examples of this is carbon-12 and carbon-14, okay? Both are carbon, which means they still have the same atomic number of 6. They still have the same number of protons, which is also 6. But they might have different number of neutrons, right? And I'm going to tell you now that this is your mass number. This is your mass number. So if I have a carbon-12, that means I'm going to have 6 neutrons versus 8 of carbon-14. Remember that the number of protons, right, never changes. Okay? Every carbon atom will have 6 protons. However, my number of neutrons can change. Let us review, right, what the sum of protons and neutrons of an atom give us. Okay, read this question, think to yourself. If you said mass number, you are correct. Okay, so if mass number is the sum of protons and neutrons, okay, and we look at an isotope, even though isotopes have the same number of protons, they're going to have different number of neutrons, which means that this number right here, your mass number of all isotopes, are going to change. Before we get into some practice, let's look at what I mean by an isotope. Okay. This is a diagram of 3 different types of hydrogen. You notice that they have different names, but they are all hydrogen. And I know that because I can look at my number of protons, right? In this atom here, I have 1 proton. In this atom here, I also have 1 proton. And in this atom here, I also have 1 proton, right? So they all have 1 proton. 1 is their atomic number. And if I look on my periodic table, the element that has an atomic number of 1 is all hydrogen. The biggest difference here, however, is if I look at this atom of hydrogen, I don't have any neutrons. It's just 1 proton, 0 neutrons. This guy over here has 1 proton, so still hydrogen, but instead of 0 neutrons, it has 1 neutron. And in this guy at the very end, I still have 1 proton, so I'm still hydrogen, but now I have 2 neutrons. Okay? My element is still hydrogen. However, my nucleus changes. I have more neutrons in my 3rd atom of hydrogen than I do in my 1st atom. Okay? These are all isotopes of the element hydrogen. Another example that we have is sodium. Okay, it's kind of weird. Na means sodium. You guys can see that if you look at your periodic table of elements. And if I zoom in on my nucleus of sodium, okay, and I compare the 2, I see that I still have 11 protons in both of them. Okay, it's sodium. They have to have 11 protons. However, in my atom on my left, I have 12 neutrons. So my mass number is 23. On my right side, though, I have 13 neutrons. It's still sodium because my number of protons didn't change, but my mass number is now 24. As I said in the example with hydrogen, I still have sodium, right? However, they're different versions of sodium. Okay, so my element of sodium and an atom of sodium can differ in my number of neutrons, and thus my mass number can also be different. One last example I have here is helium. Okay, the red circles in each of my atoms is going to be my protons, right? So I have 2 protons in each of them. But you see my number of yellow circles changes. The more neutrons I have, the greater my mass. And so the more neutrons I have, my mass number will be getting larger. In this case, helium has a mass number of 5 because I have 2 protons and 3 neutrons. I have a mass number of helium with 6, 7, and 8. And that all depends on my number of neutrons. There's still helium regardless because we only have 2 protons in each. But my number of neutrons are changing. Yesterday, we had also learned that we have a nuclear notation to show our atom, right? If we go back to this slide, we know that this is my nuclear notation. However, we can also use this type of notation to describe our isotopes. And this is what we call isotope notation. Okay? At the very front, we have my chemical symbol, which we know if we look at our periodic table, it's the 1 or 2 letters that are in each element. Or I can write my chemical name. So instead of putting He, I could write the full name helium. I'm going to put a dash, and then the number that comes after it is your mass number. And as a reminder, that is protons plus neutrons, right? So in this element, or I should say in this atom of helium, my mass number is 5. I know that helium has 2 protons, so I must have 3 neutrons in helium-5. Okay. So based on that, let's look at some questions. So I want to know how many protons, electrons, and neutrons there are in phosphorus 32. So I want you guys to pause the video right now, and I want you to write how many protons, electrons, and neutrons I would have. If you guys said that, sorry about that pause, guys. My cat literally just jumped up on my computer. Anyways, if you said that phosphorus 32 has 15 protons, you are correct, right? Phosphorus, if you look on your periodic table, phosphorus has an atomic number of 15. So it's going to have 15 protons. And we also know that in a neutral atom, the number of protons equals my number of electrons. So I must have 15 electrons. But now I need to solve for neutrons. If 32, we know, is our mass number, and I have 15 protons, I just subtract the 2 to find my number of neutrons. So my number of neutrons for phosphorus is going to be 17. Okay. We can do the same thing for this second problem. Finding the protons, electrons, and neutrons in a neutral atom of potassium 39. If I go onto my periodic table of elements, I can find that potassium has an atomic number of 19, which means that I'm going to have 19 protons. Because it's a neutral atom, protons equals electrons, and I'm going to have 19 electrons as well. Neutrons is found by taking the mass number of 39, subtracting my number of protons, which is 19, and I'm going to have a total of 20 neutrons. We talked the other day about average atomic mass. Okay, there's two things that has the word mass. Mass number that we said cannot be found on the periodic table. And the other one is the atomic mass, which is the decimal point number on the bottom of each element on the periodic table. Your average atomic mass is the weighted average mass of all naturally occurring isotopes of that element. Okay? So if we have carbon 12, carbon 13, and carbon 14, what we do is we look at how often they occur. We weight their masses, okay? Add them all up. It's kind of a complicated process, but overall, our average is going to be about 12.01. The same here happens for chlorine, right? If we took all of the isotopes of chlorine, looked at how often they appear, and find the average of all of those masses, my average atomic mass is 35.453. Okay? So the average atomic mass of an element is the sum of the mass contributions of each isotope. You guys do not need to know how to calculate this average. Okay, but you need to know that this number here, your average atomic mass, is not the same as your mass number. Okay, mass number is a whole number. It is protons plus neutrons. Average atomic mass is a decimal number based off of all of the mass numbers of each isotope. With that being said, what I want you guys to do right now is I want you to fill out this chart in your notes, okay? So you are given an isotope notation here. I want you to use your periodic table to find the chemical symbol, right? So your chemical symbol of aluminum, right, if I look on my periodic table, is going to be Al, okay? And if I look at my periodic table with Al, I can see that I have an atomic number of 13. And I know that my atomic number of 13 is also my number of protons. My number of protons in a neutral atom, and all isotopes that we're going to be talking about right now are neutral atoms, means that my number of protons equals my number of electrons. So if I have 13 protons, I must have 13 electrons. And finally, to find the number of neutrons, okay, I know that my mass number minus my number of protons will give me my number of neutrons. So if I have a mass number, in this case, it's that number that comes after aluminum, and that number is 27, and I subtract my 13 protons, I get 14 neutrons in my element. So what I want you to do is I want you to fill out the other 3 rows. Once you do that, check the solution station, okay? And then sit tight because we are about to do a group activity on isotopes.